subscribe and click the bell icon to turn on notifications.
In the last lesson, we started to take a look at the SUM function. And as I said, the SUM function is by far the most popular function in Excel and one you'll find yourself using all the time. And all the SUM function does is it takes a range of numbers and it will add them together. And as you get into more complex formulas, you can use the SUM function for many different things and combine it with other functions to make it really powerful. Well, let's not get too far ahead of ourselves at this stage, but let's delve into the SUM function in a little bit more detail. Now, once again, we have a very basic spreadsheet here. We have some years running across the top and some months of the year. And then we just have some random numbers here, possibly sales figures, something along those lines. And what we want to do is we basically want to complete the total for each of the different years. Now, as we've already seen, we can simply click in the cell, type in equals, and as we start to type in the word sum, it's going to come up in the list below. We can press tab to put that first bracket in. And then all we need to do is select the list of numbers that we want to add up, in this case C3 to C14, close off the bracket and hit enter to get our result. Once again, we have that little green triangle in the corner, and I'll explain what that is in a couple of moments. Now, there are other ways that we can perform this SUM function. Now, it might be that when you're first starting to learn formulas, you don't particularly like typing functions directly into the cell. And I know that a lot of people who are new to Excel prefer to use the functions dialog box to construct their formulas. So let me just show you what that is, and then you can decide for yourself which method you prefer. So instead of typing equals sum into this cell, what I could do is jump up to this little FX button. And you'll notice here it says Insert Function. It's also worth noting that we have this button on the Formulas tab as well. It's this one just here with the keyboard shortcut of Shift F3. So when we click this, it's going to open up the Insert Function dialog box. And this is a really nice method to use if you're not entirely sure what the function name is that you need to use. You can see at the top here, you can search for any function available in Excel, or you can browse through the different categories of functions. Now I'm going to select all just here, because what I could do is I could type a brief description of what I want to do. So maybe if I just type in add numbers and click on go, it's going to pull up all of the functions that will help me do that. And I can see that one of them in there is the SUM function. Now I can double click to select this, and it's basically going to open my function arguments. Now remember, when we're typing the function into the cell, these function arguments appear in that little screen tip underneath where we're typing. And this is basically exactly the same. It's just saying provide the numbers that you want me to add together. And you can see here it's made a good guess based on where I'm clicked as to the numbers that I want to add up, D2 to D14. And if I check my spreadsheet, that's not quite correct because D2 is actually a date. So what I'm going to do is I'm just going to remove those numbers and make my selection again, which is D3 to D14. Notice it puts the formula in the cell for me, click on OK, and then I get my result. So that's another method you can use, not only with the SUM function, but with any function that you're using in Excel, the functions dialog box. Now, another way that we can very quickly add up numbers is to use the Auto Sum button. Now, Auto Sum you're going to find on the Formulas tab in the Functions Library group, and this is one of those double-sided buttons. So I can click the top half or I can click the lower half. Now, if I click the lower half, it's going to show me the different functions that I can use Auto Sum with. So I can use it for other functions aside from sum. However, the default action for the Auto Sum button is to use the SUM function. So that means I can just click the top half of this button. So if I do that, notice what happens. Again, it tries to select the data that it thinks I want to add up. And most of the time, this selection is fairly accurate. But again, if I look at my data, I can see that within this range that it's selected, it's also including the column heading, because effectively the column heading is also a number. Now what I could do in this scenario is I can simply adjust my range. Notice I have these marching ants around the outside, and in the corner there I have these little blue squares. As I hover my mouse over, it allows me to adjust the selection. So I'm going to move it down one cell, and then I can simply hit enter to complete my sum formula. And an even quicker way of invoking AutoSum is to use the keyboard shortcut, which you can see there is Alt plus equals. Now again, if I do Alt plus equals, it's going to make the cell selection, but for this example, I need to readjust that cell selection so it doesn't include the date, and hit enter. So a few different methods that we can use there to quickly input a sum formula. Now the final thing I want to talk about here are these little green triangles in the corner of each of these total cells. What are they and why are they there? If you see a green triangle, this is some kind of warning. And warnings are always worth checking into further so you can determine if this is actually an error that needs to be fixed or if it's something inconsequential. Now when I click on a cell that has one of these green triangles, notice that I get a little icon next to it, which is a little warning icon. And if we click this is kind of going to give you an idea as to what the problem is. So I can see here at the top of the list it says formula omits adjacent cells. So what this is basically telling me is that in this sum formula, and if we look in the formula bar, C3 to C14, it says it's found other data nearby that I haven't included in my formula. And that would be correct, because I have these dates at the top here, which are effectively numbers to Excel, but to me they're dates and I don't want them included in the formula. So that is what this error is referring to. It's basically saying, hey, you've missed out a number in cell C2. Do you want to correct this before you go on? Now I know that these years are not supposed to be included in these formulas. So what I can safely do here is select all of the cells where I have this little warning, click the drop down and just say ignore error to get rid of them. So far in this course, we've looked at 3 of Excel's big 5 basic functions that everybody needs to know. So it's now time to finish off this little list with the final 2. And the final 2 functions that everybody needs to know are the min and the max functions. Now what the min function does is that it will return the lowest value in a range of cells. And as you would expect, the max function does the exact opposite. It will return the maximum value in a range of cells. So these are pretty simple to construct. Let's start with min. I'm going to type in equals min. I'm going to press the tab key to select it from the list and put in that first bracket. And once again, we have some very simple arguments. We're just required to select the numbers or the cell range that we want to find the minimum value of. So I'm going to select this cell range just here, C3 to F3, and what this is going to do is tell me which value is the lowest. So when I hit enter, it's telling me that 6247 is the lowest value in that range, so I can see at a glance that for January we had the lowest sales in 2019. I can do exactly the same for max. Let's type it in, let's select our cell range, close the bracket and hit enter, and now I have the maximum value, which was in 2021. Now once again, I'm going to want to copy all of these formulas down both of these columns. So let me show you another way that you can very efficiently do this. I'm going to select the 2 formulas that I've already done and all of the other blank cells. And if I press the keyboard shortcut Control D, that's going to copy that formula down each column. And if we just double check one of these, so let's double click somewhere down here, just to double check that it's actually calculating correctly. So C9 to F9, the lowest value there is 5538, and I can see that yes, that is correct. So Control D is another really useful little shortcut when it comes to quickly copying a formula into other cells. Another one of the big 5 functions that all Excel users need to know is the average function. And the average function is pretty much what you would expect it to be. It's a function that helps you find the average of the values in the selected cell range. And much like the other functions that we've looked at in the last few lessons, the sum function and the count function, we can either type this function directly into the cell or we can use the functions dialog box. So let's take a look at how the average function works. So on this worksheet, I have some years running across the top and then again some months running down column B. And then we have some values in this table. And what I want to do is at the end here in column G, I want to find the average amount of sales for January across all 4 of these years, 2018 to 2021. So for this, we can simply type in average into the cell. Once again, as soon as you can see it in Excel's IntelliSense menu, you can just press the Tab key to select it. And we have very similar arguments to the sum and count functions. Here, Excel just requires us to select the cell range that we want to find the average of. So I want to find the average of these 4 cells, C3 to F3. I'm going to close my bracket and I'm going to do Control Enter so that I stay in the same cell. And there I have the average sales figure. So really nice and straightforward. Now, of course, we've seen how we can do this using the functions dialog box. It's a simple case of searching for the average command, double clicking, and then we can go in and select the cell range that we want to find the average of. So pretty much the same as what we've done in the last 2 examples. So just to finish off this lesson, let's jump up to the Formulas tab, and we're going to go to the Auto Sum drop-down. Because notice in there we can also use Auto Sum to find the average. So if we click Average, again notice it's made an incorrect selection. So all I need to do here is select the cells that I actually want to work with, Control Enter to stay in the same cell. Now if you have a scenario like this where you need to complete the averages for a number of different values like we have here, we need to complete these average totals, you don't need to go to every single cell and complete an average formula. And this is going to lead us on nicely to a lesson that we're going to do a bit later on. Because what we have in Excel is the ability to autofill or copy formulas down. And this is such a useful time-saving utility. Now if I hover my mouse over cell G4 where I have my last average calculation, notice in the bottom right hand corner I have that little green square. That is my autofill handle. So if I want to copy this formula down to fill the rest of these cells, I can simply drag all the way down like so, or alternatively, and I'm just very quickly going to Control Z to undo that, I can double click and it's also going to copy that formula down. And notice if we pick any of these, so let's go to this cell just here, G9, notice that the references C9 to F9 are highlighted in blue in the formula, and it's also showing me the cells that that formula refers to in the table highlighted in blue as well. And I can see that as this formula has moved down, Excel has automatically adjusted the cell references that it needs to use for this formula. And that is what we call relative referencing. When we drag a formula down, Excel will adjust the cell references accordingly. And again, we're going to talk more about that a bit later on because there are 2 other types of referencing aside from relative, and that is absolute and mixed. But for the time being, just be aware of this concept of relative referencing when you copy formulas down. Another function that belongs in the category of the big 5 functions that everybody needs to know in Excel is the count function. And what this function allows you to do is basically count the number of items in a range or a list. So let's take a look at a basic example because there is a very important point here that you need to understand. Now in this worksheet, I just have a list of student names and I have the score that they've achieved in a test. And basically all I'm trying to do here is count the number of students that took a test. So I just want to count the number of items that I have in this list. Now bear in mind that this list is a very short list and this is probably something I could just do visually. But again, remember with all of these examples, imagine if you have a list of thousands and thousands of students. That is where the count function is going to be really useful. So what we can do here is we can type into the cell equals, and this function is simply called count. And notice again as I start to type it in, Excel's IntelliSense is pulling up a list of all of the functions that it finds in its library related to count. And if you find the one that you want to use, and if the one that you want isn't at the top of the list, you can use your arrow keys to move further down and select the one that you want. Also notice that with count highlighted, I get a little bit of informational text to the side which tells me what that function does. So it says, counts the number of cells in a range that contains numbers. And that is the really important part, in a range that contains numbers. So let's press the Tab key to make our selection and put in that first bracket. Now our arguments here are basically the values that we want to count. So I want to count the number of students. So I'm going to go across to my little table. I'm going to select all of the student names, so that I have my range B3 to B15. I'm going to close off my bracket and hit enter. I get a result of 0. Now why is that? Well, it's down to that very important part of instructional text. The count function will count numbers in a list. So because I selected these student names, which are effectively text for my formula, that's why I'm getting an answer of 0. If I double click to edit this formula, and instead of cells B3 to B15, I'm going to count using the test scores instead. So this time my range contains numbers. I'm going to close off my bracket, hit enter, and now it's working. It's telling me that I have 13 items in the range that I selected. So what do I do if I want to count anything in the cell, regardless of whether it's text or if it's numbers? Well, for that, I need to use a slightly different function. So let's double click on our cell and I'm going to delete everything out. So if I want to count basically all, I would use the count A formula. Notice this time it says counts the number of cells in a range that are not empty. So it's not going to count empty cells either. So now that I'm using count A, which will count all or count everything, if I open a bracket, I can use either the student range or the test score range, and this formula should work. So let's use the student name because this is the one that didn't work when we were just using count. Let's close the bracket, hit enter, and now I'm getting the correct result of 13. Now, how does this work if we have blank cells? Well, let's go in and delete out Olivia from this list. So now effectively I have a blank cell in this cell range. Notice immediately as soon as I did that, the number of students decreased to 12. So count A doesn't count blank cells. What about count? Well, let's try that. Let's double click. Let's type in our formula again. Let's do count. I'm going to count the test scores because with count, we can only count numbers. Close the bracket and hit enter. And again, that also gives me 12. So it also doesn't count the blank cells. Now, what about if I just wanted to count the blank cells in a range? Well, we have another count formula that we can use for that as well. And that is count blank. I can see it's the third one in my list, so I'm going to use my arrow keys to go down. Tab key to select it, and this time I just need to select my range of cells. So if I select these student names, cells B3 to B15, and hit enter, it's returning the result of 1 because in this range it's found one blank cell. So there's 3 formulas there related to counting items. Count, which will count numeric values in cells, count A, which will count anything, and count blank, which will count just the blank cells. Now I'm going to Control Z a few times just to put Olivia back into my student list. Because remember, with these formulas, you can also use other methods as well. So we looked at previously the functions dialog box. We can use that for count as well. So if I click the FX icon, I could go in here and search for count. There it is at the top of the list, and basically I can then go in and select the values that I want to count. So I'm going to select the test scores, click on OK, and the formula works. I could also use that auto sum button. So if we go back to the formulas tab, click the lower half of auto sum, we can also use this to count numbers. Now notice a problem as soon as we do this. Because the cell where I want my result to be returned is far away from the actual data, it doesn't know which values I want to count. So it's just put the count formula in there for me, and now it's asking for me to select these values. So I would need to go in, select the range, and hit enter. If I was doing this formula directly underneath where I have these numbers, if I choose auto sum and count numbers, because the result cell is right next to the numbers that I want to count, it's recognized that those numbers are there, and it's automatically input the cell range for me, so I just need to hit enter. So just be aware of those little things when you're using things like AutoSum. But that, in its essence, is how you can construct 3 different types of count formula. In this section of the course, we're going to dive into the magical world of using logical functions in Excel. Because logical functions are some of the most important functions that you can know or have in your toolkit when you're working in Excel, particularly if you're an intermediate user. And what logical functions help us do is basically make decisions. Now, there are quite a few different logical functions. You'll find them on the Formulas tab in the Logical group of the function library. And you can see all of them sitting in there. And we're going to use quite a few of these throughout the balance of this section. But what I wanted to make sure that we do in this first lesson is just do a quick recap on some of those basics, just to make sure that we're all on the same page and we're starting from the same baseline. Because it's really important to understand the concept behind how logical functions work before we can move on to doing more complex calculations using things like ifs, SUMIFS, COUNTIFs, and nested if statements. So let's talk about logical statements in their most basic form first of all. And we're going to do this using an example because it's always the best way to visualize this. So on this first worksheet, I have a very small table, and this lists out some expenses. So we have the person's name in here, we have the total of their expenses, and what I want to do is work out if an approval is required. Now we have some additional information next to this that says expenses over the following amount must be approved. So if the expense is over $1,000, then it needs to be approved by a manager. So I can work this out by using a very simple logical statement. Now, what exactly are logical statements? Well, it's basically like performing a test. So in this particular example, if we take the first expense just here, I would want to construct a logical statement that says if this value in cell B5 is greater than or equal to this value in cell G5, then it needs to be approved. And I want to perform that same test on all of these expense invoices. Now, when we're doing things like this, we use what we call operators. And you can see I've just pasted in a little picture of a table that shows different operators that you might be using in your logical statements. So things like equal to, greater than, less than, greater than or equal to, so on and so forth. So let's do this first one just here. We're going to type in equals to let Excel know we're about to do a formula, and this is very straightforward. We perform our test. So is the value in cell B5 greater than or equal to, we're going to say that because if it's 1,000 dead on, it needs to be approved. Is it greater than or equal to the value in cell G5? Now remember, if you want to copy this formula down, we don't want that figure in cell G5 moving, so we need to lock it by pressing the F4 key and making it absolute. Now if I hit enter just here, it's given me a result of false. And what I can do is I can now copy that formula down, and I can see here that all of the results showing as true are the invoices that are greater than or equal to 1,000 and need to be approved. Now notice here that all of my answers are either true or false. And if you perform a logical calculation in this particular way using these operators, the output is always going to be true or false. Now that might be absolutely fine for whatever it is that you're doing, but sometimes it might be that you want to make this more meaningful. So instead of it saying false just here, I might want it to say okay. Instead of saying true just here, I might want it to say approval. So effectively what I might want to do is attribute meaning to the true and false values. And I'm going to show you how you can kind of move on from this and do that in the next lesson. But for now, let's just get this concept of logical formulas straight in our head. We perform a test. Now, because of the way that I've set this up, if this threshold in cell G5 was now to change, so maybe this now changes to 1200, notice that all of my results update. If I was to change this to 500 and hit enter, everything is now true. Okay, so a really nice effective way of putting this formula in and making it dynamic and easy to update. Now, just to go back to changing these values and adding meaning to them. In order to do that, instead of just having our basic logical function, we would need to turn this into an if statement. And that's basically what an if statement allows us to do. It's basically this same logical formula, but it allows us to attribute more meaning to the results. And we're going to cover if in a lot more detail in the next lesson, but let me just show you how we would change these values. Now I'm just going to delete these out. Now what we're going to do is we're going to wrap basically our logical statement inside an if statement. Now notice here it says check whether a condition is met and returns one value if true and another value if false. So the first argument here is our logical test. So our logical test is pretty much what we just did. Is this value greater than or equal to this value? F4 to lock. Press comma to move on to the next argument. This is where we can attribute meaning to the true or false result. So it says value if true. I can now define what I want it to say if the result is true. So if the result is true, effectively the number is greater than 1,000 and it has to be approved. So in quote marks, because text in formulas must always be in quote marks, I want it to say approval, comma. If the value in the cell is false, I don't want it to do anything. I just want it to say okay. Let's close the bracket. So I've attributed meaning to the true and false results. Let's hit enter. And I can now double click to copy that down. And it's a lot clearer for me to see which invoices need to be approved. So simply by adding in that if statement, we've changed the rather generic true or false output to something that's more meaningful and easier to understand. And that's basically what an if does for us. Let's look at a few more examples of if in action. Now in this first table, again, a very small table, we have some test scores. So we've got some student names and we've got the score they achieved in a test. And the pass mark is 85. So I want to create an if statement that says if the value in this cell is greater than or equal to the value in this cell, 85, I want a result of pass If it's not, I want a result of fail. So again, we're going to use if. Our logical test is if the value in B4 is greater than or equal to the value in H3. We're going to copy this down, so F4 to lock. If that is true, then they have passed. Hooray! If it's false, then unfortunately they have failed. Close the bracket. I'm going to do a Control Enter to stay in the same cell. Copy that down and I get my results. So much more meaningful than simply true or false. Let's take a look at another example of if. And we're going to add in a little bit more complexity just here. So in this second table, we have some products, we have the weight in kilos, and then we have the price for those products. And I'm actually just going to change these to dollars just to keep everything in this spreadsheet consistent. Now, what we're going to say here is that if the weight of the product is greater than or equal to 30 kilos, then there's going to be a 20% shipping fee. And that shipping fee is going to be 20% of the price. So let's construct our if. What is our logical test? Well, if the weight is greater than or equal to 30 kilos, again, F4 to lock. Now, what do we want it to do if that is true? So if the product is greater than or equal to 30 kilos, well, there's going to be a 20% shipping fee. So our true result is going to be a calculation because we want it to work out that shipping fee. So if it's true, we want to do the price multiplied by 20%. F4 to lock, comma. If it's false, there's going to be no shipping fee. So we're going to put a 0 on the end there. Close our bracket, Control Enter to stay in the same cell. And if I copy this down, I should find that the only two products that have a shipping fee are the ones that are greater than or equal to 30 kilos. And this amount should be 20% of the actual price. So we can incorporate formulas into our logical if statements as well. Now, I just want to finish off this lesson by running through a couple of other basic logical statements, and that is and or. Now, what and allows you to do is basically perform two logical tests. So we're taking this example of test results again. So we have our students and we have the score they achieved in test 1 and the score they achieved in test 2. And what we're going to say is that they need to have achieved above 75 in test 1 and above 65 in test 2 in order to get a result of pass. So we're effectively performing two logical tests here. So if we want to do more than one, and we need both of these to be true to get a positive result, we use the AND formula. Notice the arguments logical 1, logical 2. So our first logical test is if this score is greater than or equal to the pass mark for test 1, F4 to lock, and the second test score is also greater than or equal to the pass mark for test 2, F4 to lock. Both of those have to be true in order to pass. Now I'm going to hit enter. It's going to give me a result of true or false. If I want to add meaning to this and have pass or fail, I would need to edit this formula and wrap it in an if statement. Remember, that is how we add meaning. The first argument for our if statement is the logical test. Well, those are being generated by our AND formula. So I can go straight to the end and just define what I want it to say. So if both of those are true, it's going to be a pass. If both or one of those are false, it's going to be a fail. Close the bracket, hit enter, and now I've combined two functions together to perform two logical tests, and I've given them meaning using if. OR works in a very similar way, except what we're saying here is that they need to have achieved the pass mark in test 1 or in test 2 in order to achieve a result of pass. So we're going to go straight in and type in our if formula. Our logical test, well, we want to generate this using our OR calculation. Logical 1, logical 2. So if score 1 is greater than or equal to the pass mark, F4 to lock, or score 2 is greater than or equal to the pass mark for test 2. F4 to lock. Close off our OR. We're now back into our if statement. We can now set up the value if those are true. So if that's true, we have a pass. If it's false, we have a fail. Control, Enter, and then I can copy that down. So notice here that the only one that comes up as fail is where both of these scores are less than the pass marks. So we've looked at basic logical functions there. We've seen AND, we've seen OR, and we've seen how we can add meaning by using if.
Hello everyone. Welcome to a new tutorial from Simon Says It. In this video, I'll show you how to use the match function in Excel. Excel consists of a variety of functions that help in performing a variety of operations at ease. If you want to find the position of a particular value when using Excel tables or pivot tables, you can use the match function. The main purpose of the match function is that this function is used to search any data in an array of cells and returns the relative position of that particular data. The syntax of the match function takes 3 arguments: the lookup value, the lookup array, and the match type. The lookup value is a mandatory field. This argument denotes the value you want to search in the array. The lookup array is also a mandatory field. This denotes the data array or the cell range from which you want the function to look for the lookup value. Match type is an optional field and can take only the values -1, 0, and 1. This field defines how you want the function to search the lookup value in the lookup array. When the match type argument is 0, the match function searches for and finds the first occurring value in the array exactly equal to the lookup value. When the match type value is -1, the function finds the exact or the smallest value greater than or equal to the lookup value. However, when using this match type, make sure the array is sorted in descending order. When the match type is value 1, the match function finds the exact or largest value lesser than or equal to the lookup value. However, the values in the lookup array must be arranged in ascending order. Since this is an optional field, the default value will be 1 even if you mention it in the formula or not. Let us now see how to use the match function in Excel with the match type 0. To find the exact match for the particular value, first, choose a destination cell. Enter the formula equals match and pass the arguments as the value, cell range, and the match type. Press Enter. This gives you the position of the search data. That is all, everyone. The match function can be a very helpful tool that helps you find the relative position of the value. This can help find, replace, or make any changes to the data. In this video, we saw how to use the match function in Excel along with its use cases. Thank you.
In the last 3 lessons, we've spoken mainly about how we can split up text strings, and we've seen lots of different methods that we can use to do that. But what about if we want to do the opposite? Well, we saw how we can use flash fill to combine values together, but we can also use a text function called CONCAT. And you would use CONCAT whenever you want to join values in different cells together and make them one string. Now, before we get on to using the CONCAT function, let me show you another way that you can join text strings together. Because we can simply use the ampersand symbol to join cells together. So, for example, if I want to join together the first name and the last name, what I could do over here is type in equals, select the first cell, and then I could use the ampersand sign. So if I do ampersand and select the second cell, so this time the last name, that's going to join these 2 text strings together. Now if I press enter, let's take a look at it. Well, yes, it has joined them together, but I don't have a space in the middle. So I also need to account for the space. So let's double click to edit the cell. What I need to add in here is after the first ampersand, I need to specify that I want a space between the names. Now, space counts as text, so it needs to be enclosed in quote marks. So quote, space, quote, and then another ampersand to join the space with the text in cell B4. So now when I hit enter, I get exactly what I'm looking for. And I could copy that down, and it's going to do the same for all of those names. So you can use just an ampersand symbol if you want to join text strings together, but you need to make sure that you do account for things like spaces, dashes, commas, things like that. So very straightforward. Now, concat allows us to do something very similar, but this time we're using an Excel function. So let's do the same thing, but this time we're going to use concat. Now, when you start to type in concat, you'll see that you get two things come up in the list, concat and concatenate. Now, concatenate is what this function used to be called, and they changed it a few years ago to concat. But concatenate does still exist in the Excel database, but know that it has a warning symbol next to it, letting you know that that is kind of an old function and concat is the newest version. So, concat works in a similar way. Our argument is the first piece of text, so we want the first name, comma, text 2. Now again, if I was just to select the last name and close the bracket, it's going to give me that with no space. So what I need to do in here is my text 2 needs to be the space. So again, quote mark, space, quote mark, comma. And then when I hit enter, I'm going to get the format that I need. So slightly different to using ampersands, and I'll leave it up to you which of those methods you find easiest to remember. Now, just to finish off this exercise, let's take a look at a slightly more complex example. Now, this time I want to concatenate the name and the job title, and this is the format I want to use. So I want a space separating the first and last name, and then I want a space dash space, and then the job title. So let's do this both ways. If I was just using the ampersand symbols, what I could do here is I could say I want A4, ampersand. We need a space in there. So quote marks, space, quote marks, ampersand. Then we want the last name, ampersand. And then we want space dash space. So quote marks, space dash space, close quotes, ampersand, and then we want the job title, so we can select the cell. Let's hit enter, and we get exactly what we're looking for. I could then copy that down for all of the others. So that is how we would use the ampersands to concatenate slightly more complex text strings. What about if we were to use the CONCAT function for this? Is it any simpler? Well, let's see. Text 1 is Mary, comma. Remember, our space is our next piece of text, so quote mark, space, quote mark, comma. We then want our text 3, which is the last name, comma. Then we want space dash space, so quote mark, space, dash, space, close quote mark, comma, and then finally we want the job title. Close off the concat function, hit enter, and again we get exactly what we're looking for. So that is how ampersand and concat work. So now we've seen how we can join text together, let's take a look at doing that on our sales worksheet. So just for this example, we're going to concatenate the country and the product name again. So let's add in a column, Control-Shift+, and let's use concat to do this. So I'm going to type in concat, text number 1. So our first piece of text is going to be the country. Now I want this to have space, and then I want the product name, but I want the product name to be in brackets. So my text 2 is going to be a space, quote mark, space, quote mark, comma. What is my text 3 going to be? Well, I actually want a bracket in there. So again, in quote marks, because a bracket is considered text, I'm going to do an opening bracket, close the quote mark, comma. Then I want the word Kensington, comma, and then I want a closing bracket. So quote mark, close, quote mark, and then close off the concat function. Now that looks like a really weird function when you just look at it with all of these quote marks in there, but hopefully when we hit enter, we're going to get exactly what we want. And we do. And we can double click to copy that down. Now just for fun, let's see what that would look like if we were using ampersands. So equals Japan. Then we want an ampersand. Then we want a space, quote, ampersand. Then we want an opening bracket. So quote, bracket, quote, ampersand. Then we want the product, cell B2, ampersand. And then we want our closing bracket, quote, closing bracket, quote. And that is it. Hit enter and we get exactly the same thing. So once again, I will leave it to you as to which of those methods you prefer. Now we don't actually want to combine these like that, so I'm just simply going to delete out that column. In this section of the course, we're going to start taking a look at some of the most useful intermediate level functions and formulas in Excel. And the idea behind this section is really to give you a taster of the types of things that you can do with more advanced formulas to move your knowledge on a little bit from those basic formulas that we looked at earlier in the course, and really set you up for success if you plan to do the Excel Intermediate course. And we're going to start out this section by taking a look at one of the most popular functions, and that is the VLOOKUP function. Now, VLOOKUP is classified as a lookup and reference formula in Excel. And if we jump across to the Formulas ribbon, you're going to find it underneath the Lookup and Reference section, all the way down at the bottom. There it is, VLOOKUP. Now, if we take a look at this screen tip, because this is going to tell us exactly what VLOOKUP does. So it's going to look for a value in the leftmost column of a table, and then it returns a value in the same row from a column you specify. So what exactly does that mean in terms of data? Well, let's take a look at the example that we're going to use. Now, in this worksheet, I have a reasonably large data set, and this is related to movies. So in column A, we have the title of the movie. In column B, we have the year that it was released. In column C, we have the certificate it's been assigned. In column D, the date that it was released. In column E, we have the runtime or the duration of the movie. In column F, we have the genre that that movie belongs to. And then finally in column G, we have the user rating. And what we want to be able to do here is we want to be able to type in the name of a film and have it return the year, the certificate, the genre, and the rating from the table. And it's this kind of situation where we would use the VLOOKUP function. Now, the thing that a VLOOKUP relies on is a lookup value. So whatever it is that you're using to look up this information, in this case, the film name that we have in J2, that must exist in the table. So let's pull back the year using the VLOOKUP function. Now I'm going to type equals into the cell, and then we're going to start to type VLOOKUP. Notice it's come up in IntelliSense, so I can just press the tab key. Now let's take a look at the different arguments. Remember, the arguments are what we need to complete in order for this formula to work. Now, the first thing that this formula requires is the lookup value. So this is the piece of information that you're using to look up other pieces of information in the table. So for us, the lookup value is going to be the film. So whatever we have in cell J2. Now remember, this can change. I can type in all different kinds of movie names in here, but regardless of what I type in, because we're using a cell reference, it's always going to look up based on the value in cell J2, comma, to move on to the next argument. We then need to provide the table array. So effectively, this argument is asking us, where is our data? What are we looking up this information in? Well, for us, our table array is this data over here. So I'm going to select the entire table. Now let's jump up to the formula bar to carry on editing, comma. Now it's asking us for the column index number. And this is a really important part of VLOOKUP. The column index number is where you specify the column of information you want to return. So what are we looking up here? What is the result that we're expecting? Well, we're trying to return the year of the film Moonlight. So we want to return the year. Now VLOOKUP numbers columns from left to right. So the title column is column 1, the year column, column 2, certificate column, column 3, so on and so forth. So our third argument here is going to be 2, because the year is column 2 in our table array, comma. Now our final argument here is an optional argument. How do I know it's an optional argument? Well, if I take a look at the argument, you can see that it has square brackets around it. Now any argument that you see in square brackets means that it's optional, so you don't have to input anything for this. But if I do press comma, you can see the arguments that we have, true or false. So what am I doing here? Am I doing an exact match or an approximate match? And this is related to the lookup value, the film that we're using to look up the data. Well, I want to exactly match the name Moonlight in the table. So this argument is going to be false. And I would say that the false argument on the end of a VLOOKUP is the most common argument. Now, if you don't put anything on the end here, remember this is optional, it's going to do the default, which is to do a false. So I'm just going to type false on the end and close off my bracket. That is my VLOOKUP formula. Let's hit enter and see if this works. There we go. So it's pulled back the year 2016. So if we look for Moonlight in the table, and it's this one just here, you can see that yes, the year that movie was released was 2016. So we've used the film name as the lookup value in this table, and we've returned column 2, which is the year. Let's do this again. Equals VLOOKUP, tab key. Lookup value again is what we have in J2. The table array is the same thing, so I'm going to Control Shift down to select everything. Let's click back up in the formula bar, comma. The next thing we need here is the column index number. So what piece of information do we want to return this time? We want to return the certificate. So counting from left to right, the certificate column is column number 3. And we want to do an exact match of the movie name in the table. So our final argument here is going to be false. But also remember, in Excel, you can type a 0 to represent false and a 1 to represent true. So I could put a 0 on the end here or leave it blank. Close the bracket, hit enter. Certificate is R. Let's double check that. Yes, it is. Now, one way I could make this a little bit easier on myself so that I'm not having to go in and select this cell range each time for the table array is to turn this data into a table or a named range. So I'm going to create a table. Control T. Click on OK. Now my data is in a table, and on the table design ribbon, I'm going to give my table a name. So let's just call this Movies and hit enter. Now that I have this table array named, I can use it in my VLOOKUP calculation. So this time we're going to pull back the genre. And I can see that the genre is column number 1, 2, 3, 4, 5, column number 6. So equals VLOOKUP. The lookup value is the movie. The table array, this time I can use the table name. So if I start to type it in, notice it comes up underneath in IntelliSense, tab to select, comma. The column index number, I'm looking for the genre, which we've established is column number 6. And I want to do an exact match, so I'm just going to accept the default here. I'm not even going to add that final argument. Hit enter. And yes, that movie is in the genre of drama. And just to show you another way that you can do this, you could also utilize the functions dialog box. So if we go up to the formulas tab and click on Insert Function. I'm going to search for VLOOKUP. Let's click on Go. Double click to select. And now I can complete my arguments in this way. So the lookup value is J2. The table array is movies. The column index number, well, this time we want to return the rating, which is column number 7. And we want to do an exact match, so we need a false argument on the end there. Let's click on OK, and there we go, 7.5. So now what this means is that every time I change the film or type a new film into here, all of these results are going to update. So if I type in Jackie and hit enter, you can see that those results have changed to reflect this movie in the table. What about if I type in, let's go for La La Land, hit enter. Again, at the top, those results have now changed. So that is how you do a basic VLOOKUP using exact matching. Hello everyone, and welcome back to this course on Excel for Business Analysts. We finally made it all the way down to the final module of section 4. And in this module, we've been taking a look at if functions. So I want to finish off this section by just rounding it out with how you can utilize if functions along with the count and sum functions. Now, before we jump into COUNTIF, I'm just going to briefly remind you of what the count function does. So we're going back to our spreadsheet where we have our tech sales for 2018 and 2019 for the company Microworld. And you can see that just to the right of our table of data, I have count, COUNTIF, and SUMIF. So the first thing I'm going to do is show you what count actually does. Now, the count function in Excel, again, is one of those big 5 functions. It's one of the functions that everybody needs to know, and one that you'll probably find you use on a fairly regular basis. And what it does, if we take a look at the arguments for this function, is that we need to provide it with some values, and it's going to count how many values we have. So for example, if each row of this data represents a single sale, I might want to find out how many individual sales I have. I could use the count function for that. And because I'm just counting the number of items, I could really utilize any column. So I'm going to click in here. I'm going to do Control-Shift down to select all of my rows of data. And now if you look up in the formula bar, if I close off my bracket and hit enter, it's going to tell me that I essentially have 909 individual orders in my data. So count just counts the number of items. So now we understand what count does, we're going to move on to COUNTIF. Now this will essentially do the same thing, but it allows you to add some criteria into the count. For example, I might want to count the number of products that are called HP Spectre 360. That would essentially be my criteria. I might want to count all of the orders we've had for people who work at Computech. Alternatively, I might want to count the number of orders I've had where the number of items is greater than 10. And that's exactly what we're going to do. So I'm going to jump into my cell and type in COUNTIF and open my bracket. And you can see I have 2 arguments that I need to provide. And the first one is the range. So it really depends what you are counting in this particular example. So let's use that last example that I mentioned. We're going to count the number of orders where the amount of items ordered is over 10. So my range is going to be the number of items. So I'm going to click in my first cell, Control-Shift down to select the entire column. So we're now working up in the formula bar. I'm going to press comma, and it's asking me for my criteria. Now your criteria always needs to go in quotation marks. And what is my criteria? Well, I'm only counting the order if the number of items in that order is greater than 10. Close my quote marks and close my bracket. So I've provided my criteria range and also my criteria. Hit enter. And I can see there that out of all of these orders, there are 344 orders where the number of items is greater than 10. So it's a count, but it allows you to add in criteria. Now, SUMIF works in a very similar way, but instead of counting, we're actually summing. So it might be that I want to sum all of the orders where the shipping is greater than $20, or maybe I want to sum all of the items where the cost is less than $150. But in this example, what we're going to do is we're going to say equals SUMIF, open bracket. We're going to sum all of the totals that are greater than or equal to $4,000. So our first argument is the range. So we want to select our totals range. Control Shift down to select. Again, we're now working up in that formula bar, comma, we need to provide our criteria. So I'm only summing totals that are greater than or equal to $4,000. And we need our quote marks, and we're going to say greater than or equal to 4,000. Close quotes and close brackets. Hit enter. And there we go. I now have my total. It's summing together all of the items that are greater than 4,000. And again, I'm just going to apply some accounting format to that and take those decimal places down. So pretty simple to use both COUNTIF and SUMIF. Let's move on to another example. Now this time we're going to utilize COUNTIFs and SUMIFs in order to achieve our result. Now COUNTIFs and SUMIFs differ from COUNTIF and SUMIF because it allows us to use multiple pieces of criteria. So very similar to when we were looking at that IFS function. So what we have over here are a few different tables. This first table in the top left-hand corner, it's showing us the names of some salespeople, the region that they work within, the number of orders they've generated, and the total amount of sales, this time in UK pounds. And what I essentially want to do is in this first table, I want to count the number of orders that are greater than or equal to 100 for each of the regions. So essentially what I have here are two pieces of criteria for my count, which means I need to use COUNTIFs. So let's type that in and take a look at our arguments. So the first argument we have here is criteria range 1. So what exactly are we looking for? Well, we're counting the number of items in each region. So our first criteria range is the region. So I'm going to select that entire range. Now, because I'm going to drag this formula down, I don't want these cell references to move, so I'm going to need to lock that in place by pressing the F4 key to make those references absolute. Comma. It's now saying, okay, within that range, what do you want me to look for? And I want it to look for the East region, F2. I'm now being asked for my second criteria range. So my second piece of criteria is I'm looking for the number of orders. So I'm going to select the orders range. And again, I'm going to lock that in place, F4. Comma. What is my criteria? Well, I'm looking for orders that are greater than or equal to 100. Now I could directly type that into the formula by putting it in quote marks and saying greater than or equal to 100. I could do it that way. In this example, I actually have it listed out in the cell, so I can just select the cell for my criteria. Remember, that makes it a lot easier to change all of your formulas in one go. If this figure changes, it's going to update across the board. Now, if I had more pieces of criteria, I could carry on going just by doing comma, selecting my third criteria range and my third piece of criteria. But in this case, I only have two, so I'm going to close off my bracket, hit enter, and I'm then going to copy that down. And if we do a quick visual check and look at the East region first of all, which is these top two, I can see that we have 0 orders, so nobody has made any orders which are greater than or equal to 100. If I look at the West region, there is just one entry for that, so we can see that we have 1 order that's greater than or equal to 100. The North region, both of these match that criteria, so my result should be 2, which it is. And the South region, that doesn't match the criteria, so my answer is 0. So we can essentially do a very similar thing if we want to sum these sales figures. And for this, I'm going to use the SUMIFS function. So our first argument is the sum range. So I want to sum the total sales that meet my 2 pieces of criteria. So my sum range is going to be my sales range. And I'm going to press F4 to lock those in place because I intend to copy this down and I don't want them moving. Comma. What is my criteria range number 1? Well, my first piece of criteria is the region. So my criteria range is the region. F4 to lock those in place. Comma. I now need to specify what I'm looking for in that criteria range. Well, I'm looking for the region, in this case, F12. Comma. I now move on to my second piece of criteria. So I'm looking for all orders that are greater than or equal to 100. So my criteria range is my orders range. F4 to lock those in place. Comma. What is my second piece of criteria? So again, I could select cell G12. Alternatively, I could manually type that in, greater than or equal to 100, making sure it's in quote marks, and then closing off my bracket. Let's hit enter and let's just send that down. And there I have my results. So again, this is a small data set. We can do a very quick visual check. If I look at sales for East, none of those match my criteria, hence why I have nothing in my total. We only have 1 for West, so I would expect to see the same thing, 41,107. For the North region, again, we only have 1 that meets that criteria, and also for the South region as well. And of course, because of the way we've set this up, if I was to change one of these, so let's make one of these figures, let's make the other North figure above 100, let's say 101. If I hit enter, you'll see that that will now update accordingly. Hopefully that gives you more of an idea of how count, COUNTIF, SUMIF, and then COUNTIFs and SUMIFs work. Whilst VLOOKUP is an amazing function to know to perform powerful lookups, after you've been using it for a while, you're going to start to come across some of its limitations. So in this lesson, I want to just briefly talk about the limitations of VLOOKUP and then show you a better, more flexible way of performing lookups. So let's just review. Now, when it comes to VLOOKUP, if we take a look at this first example that we were using, we're looking up the part number in the parts catalogue and we're returning either the description or the price. And the way that we construct the VLOOKUP is we say look up the part number and then return me either column 2 or column 3. Now the big limitation with VLOOKUP is that your lookup value must always be to the left of what it is that you're looking up, because we can't count back columns. For example, I couldn't use the price to look up the part number using VLOOKUP, because when it comes to the part of the formula where we have to enter in a column number, I can't say count back -2 columns to get the part number. It always has to be a positive going from left to right. So the biggest limitation here when using VLOOKUP is that your lookup value either has to be in the first column or to the left of whatever it is that you want to return. Now that might be absolutely fine in 90% of scenarios that you're going to come across, but you're definitely going to come across some situations where you're going to need a more powerful and flexible way to perform lookups. And that is where index and match come in. So let's take a look at these two functions. Now, index and match are two separate functions in their own right, but you often hear them used together in the same sentence because they are used together so often to perform complex and powerful lookups. And the beauty with using index and match to perform your lookup as opposed to something like VLOOKUP is that it doesn't matter where your lookup value is in the table and what column you want to return, it's always going to work. So let's take a look at this example first of all. I have a table over here which shows me some categories, some apps, the revenue those apps have generated, and the profit. And what I want to do is be able to select an app from this drop-down list and have it return the category, the profit, and the revenue for that app. Now I'm going to be using the app as the lookup value in this table. Now the app is in column number 2. So when it comes to returning the category, I'm effectively having to look up a column going from right to left. So this is a perfect example of where VLOOKUP wouldn't work because we can't have the lookup value in column 2 and return a result from column 1. So we need a better way of doing this. Now, before we actually combine index and match together to perform this lookup, I want to show you what each one does in its own right, which will help you understand why they work so well when used together. So I'm going to click in cell H6 and let's take a look at what index does first of all. Now index has a couple of different sets of arguments that you can use here. And I would say that the first group of arguments is the one that you're going to use most of the time. Now the first argument here is array. Now the way that I like to remember this is, what is it that I'm looking to return here? I'm looking to return the category. So my array is going to be the category. And an array is effectively another word for range. So our first argument is going to be the category range, the category array, comma. I now need to provide the row number of the item I want to return. Now I want to return the category for the application OneDrive. So if I take a look at my table and find OneDrive, it's just here. What is the row number? Well, if we start at the top, 1, 2, 3, 4, 5, 6, it's row number 7. So if I type row 7 in here, close my bracket and hit enter, it's going to pull back the category of productivity. And if I take a look at that, I can see that yes, that is correct. Now I know exactly what you're thinking at this stage. You're probably thinking, well, that's a bit tedious having to manually count down to find the row number. And you would be correct. We have a very small data set here, so it's not too much of a bother for me to count down. But what if I had a data set that had hundreds or thousands of rows? I'm really not going to want to spend time counting down the rows to find the value that I need. So we need to find a way of automating the finding of this row number. So with that in mind, let's take a look at what the match function does on its own. We're going to type in equals match. Now for this one, we have 3 arguments. The last argument is an optional argument. The first argument is lookup value. Well, our lookup value is OneDrive. What is the lookup array? So where will we find the value OneDrive? Which range? Well, we're going to find it in the app range. So that is our lookup array. Do we want to do an exact match here? Yes, we do. I want to exactly match the word OneDrive in the table. So I want a 0 argument on the end. Let's close the bracket and hit enter. And take a look at that. It returns the row number that OneDrive sits in. So the match function will do what we need it to do. It's going to automate the finding of the row number. So now we know what each of those functions do. We can combine them together to perform this lookup. So let's start from the top. We're going to type in index. What is our array? Well, our array is what we're looking to return, the category, comma. Now we need to provide the row number. So this is where we're going to use our match function. So we're going to go straight into match. Our lookup value is OneDrive, cell H5. Where are we going to find that? Well, it exists in the app range. So this is our lookup array. And we want to do an exact match of the word OneDrive in the table. We need to close off our match, close off our index, hit enter, and now we get our category. And I should find that if I change this to something else, that's the same category, let's choose something else, it's going to work correctly. Let's do it again. Equals index. What is our array? Well, this time we're looking to return the profit, so this is our array just here. Row number, well, we want to use match to automate that for us. The lookup value is H5. We're going to find that value in the apps list, that is our lookup array, and we want to exactly match the word Instagram, so we want a 0 on the end there. Close off our match, close off our index, and hit enter. Let's double check, so let's find Instagram in this list. Yes, it is in the category social media, and the profit is 786.80. Now we're going to do this again for the revenue. I'm going to do this in a slightly different way so you can see a couple of other techniques. Now what I'm going to do here is I'm going to take a look at my data and I'm going to create named ranges for each of these columns. And then I can use those named ranges in my formula. Now a quick way to do this is to select everything in the table up to the Formulas tab, and then in the Defined Names group, I'm going to say Create from Selection. And I want to use the top row as the names for my ranges. Let's click on OK. So now what I should find if I click the Name box drop-down is that I have 4 different named ranges here, and they've all been named according to the column heading. If I select Category from here, that is the range that it refers to. If I select Revenue, that is the range. Now you don't have to do this, I'm just showing you a different way that you could construct this formula. I could then say index. This time I'm looking up the revenue, so instead of selecting this range of cells, I could use the named range. So we can type it in, or we can press the F3 key and select it from here. We're then straight into our match to find that row number. Lookup value is whatever we have in cell H5. Our lookup array, where are we going to find this? Well, we're going to find it in the apps list. Now, because I also have this as a named range, I can press F3 again and choose app. And I want to exactly match the name Instagram in the table. So we've got a 0 on the end. So let's just take a moment to review what we have there, because we've used 2 named ranges in this formula. And the reason why I like to use named ranges is because it does make it a lot easier, particularly if you have a much larger data set than I have here, because it means you're not having to keep selecting cell ranges, you can just use the name. But it also makes formulas a lot easier for anybody who's looking at this spreadsheet to understand. Now I need to add another bracket on the end here, hit enter, and there I get my result. Let's check to make sure this is working. Let's choose something else. Twitter, let's double check in the table, that is in the social media category. Revenue is 17,760 and profit is 800. Now that I've shown you how you can combine the index and match functions to perform a powerful, complex lookup, we're going to see how we can do exactly the same thing in a different way. And when I say in a different way, I mean using 2 brand new functions in Excel 2021, and that is XLOOKUP and XMATCH. Now, as I said, these 2 functions are brand new to Excel 2021. And XLOOKUP is really another way of performing a lookup very similar to index and match. So it has all of the same flexibility that we love about index and match, but it's a lot easier to construct. So let's use the same examples, but this time, instead of index and match, we're going to use XLOOKUP. So let's click in our cell. I'm going to type in equals XLOOKUP. Now, the first difference you'll notice here is that we do have a lot more arguments. And it's only the first 3 that are mandatory. All of the others, the last 3, are all optional arguments. Now, we're going to go through all of them just so you can see exactly what they do. But if you just wanted to do a basic lookup, you could just use the first 3 arguments. So the first argument is lookup value. So our lookup value is going to be whatever we have in cell H5, comma. What is our lookup array? So where are we going to find Google Docs? Well, we're going to find it in the apps list. So this is our lookup array. And then we simply need to specify the return array. So what do we want to return? We want to return the category. So all we need to do is select the return array. That is basically it. I could close off my formula, hit enter, and I'm going to get my answer. Now, how much easier is that than doing the same thing using index and match? Now, let's double click to go back into this formula because I did say I wanted to run through all of these arguments. So the next argument is if not found. So we have some additional things we can specify here. So if the lookup value is not found in the table, we can choose to return a value that we specify. So that might be a piece of text. Remember, text needs to go in quote marks. So I might just want to say here, not found. Comma. I can choose what type of match I'm doing. Do I want to do an exact match? Do I want to do an exact match or next smaller item or next larger item? Well, I'm going to do an exact match. I want it to exactly match Google Docs. And then the final optional argument that we have here is the search mode. So with this particular argument, we can choose which way or how we're searching through this table. So I can choose to search from first to last or last to first. Now, if I do first to last, let's type 1 as our final argument. It's going to return the result of productivity. Now we're going to do XLOOKUP again to return the profit and the revenue, but we're going to do this in a slightly different way again. Now so far we've seen how we can create named ranges and use those in our formulas, but what about if I want to put this data in an Excel table? Well, what I'm going to do is click in my data and press Ctrl T. Yes, my table has headers. Let's click on OK. Now, I don't particularly like this formatting, so let's change that. That looks a little bit better. And I'm going to give my table a name. So let's call this apps_list and hit enter. So now what I could do when I'm constructing this XLOOKUP, let's do it again. So XLOOKUP. Our lookup value is what we have in cell H5. My lookup array is a table this time. Now I've called my table apps list, so I'm just going to start to type it, double click to select that table. Now it's selected the entire table, but my lookup array is just the app column. So what I can do here is press the square bracket and it's going to show me all of the different columns of that table. So I can then go through and just select the app column. Press the Tab key to select it and close that bracket. So now I've isolated that column. Comma. What is my return array? Well, my return array this time, I want to return the profit. So again, I could use my table columns. Let's choose the table, square bracket, and I want to choose the profit column this time. Tab key to select and close that square bracket. Now, if I want to essentially skip over an argument, so I don't particularly want to have any if not found text, I can just press 2 commas to move on to the next argument. I want to do an exact match and I want to search first to last. Close the bracket, hit enter, and it's going to return my result. Let's double check to make sure that this is correct. So let's find Google Docs and I can see that yes, the profit is 1166. Now for our final XLOOKUP just here, I want to focus in on that search mode. So which way we're searching through our data. So let's do our XLOOKUP one more time. Our lookup value is H5. Our lookup array, well, I'm going to use my table range again. I'm looking up the app in the app column. The return array this time is going to be the revenue. So let's select our table and the column. I'm not going to put in any if not found text. Let's press another comma to go on to the next argument. I want to do an exact match and I'm going to search first to last. Close the bracket, hit enter, and I get my result. Now with that search mode, searching first to last, that works perfectly fine for the data that I'm using. But what if I have Google Docs listed twice in this table? So what I'm going to do is on the bottom here, I'm just going to add another row for Google Docs. And we're going to assign it to a different category. So let's say utility. It's going to be Google Docs again, and let's just give it a value of 50,000 with a profit of, let's say, 5,000. Now I'm just going to expand my table out to accommodate that new data. So now effectively I have Google Docs listed twice in this apps list. Now currently, if we use the revenue as an example, it's showing me the revenue of the first Google Docs that it finds in this list because I chose to search from first to last. But if we double click to edit this formula, what I could do is I could change this to something different. So let's do search last to first, -1, and hit enter, and we get a completely different result. This time it's searching from the bottom upwards, and the first Google Docs entry it comes to is this one just here. So it's returning a result of 50,000 for the revenue. So that's how that search mode option works. But as I said, in its most basic form, if you don't want to use all of those optional arguments, you just have 3 arguments: lookup value, lookup array, and return array. Super simple. So now we know what XLOOKUP does. What does XMATCH do? Well, XMATCH is fairly similar in many ways. We have a lot more arguments than we do when we're using just the basic match. So what I could do up here is if I want to go back to using index and match, I could do an index with an XMATCH instead. Our array is the category, so let's select it. And notice that because I have this data in a table, it's automatically going to put the table name and the column name in for me. Row number. Now, if you recall previously, we were using the match function to automate the finding of that row number. But what I could do is use the new XMATCH function instead. Again, the last 2 arguments here are optional arguments. Now, my lookup value is what we have in H5. My lookup array is where I'm going to find that, so that's in this apps list. I can then choose a match mode, so I want to do an exact match, and then I also get that search mode option when using XMATCH as well. So I can choose if I want to search from first to last, last to first, or start doing a binary search and sorting in ascending order. So let's do last to first again, -1. Close the bracket, hit enter. I can see that I've forgotten to add an additional bracket on the end, so I'm going to accept the correction. And it pulls back the category of utility because it's finding this entry first because it's searching last to first. Now you can also use XMATCH on its own when not combined with index, and it works very similar to the match function on its own. It's basically going to tell you what the row number is. So the arguments are pretty similar. Lookup value. Lookup array is where we're going to find that, which is just here. My match mode is exact, and I'm going to search. Let's do first to last this time. Close the bracket, hit enter, and it's going to tell me what row Google Docs resides in from the top. So pretty much the same results that you get with match, but it's just a little bit more flexible. You have a few more options in there. So that is your introduction to 2 brand new functions in Excel 2021.
Hello everyone, welcome to a new tutorial from Simon Says It. In this video, I will show you how to count cells with text in Excel. In a spreadsheet consisting of different data types, you might sometimes have to pinpoint the cells with the text and count them to perform any function or operation. There are 3 cases that occur when you count cells with text in Excel. Let us see them one after the other. To count all the text values in a given Excel sheet, you can use the COUNTIF function along with a wildcard character. This function with a wildcard counts all the text values in a given range. To count the cells with text in Excel, choose a destination cell and enter the formula. The asterisk symbol specifies anything other than numbers to be counted, including blank spaces and special characters. However, this method does not count logical values. You can use the same COUNTIF function and wildcards to count the number of cells with text in them. This method only counts cells that hold any text value and does not count any blank cell in the given range. To count the cells which have text values in them, enter the formula. In the destination cell. This is the same as the previous case, but adding the question mark wildcard together with the star wildcard only counts the cells which have text values. There is another case that occurs when you count cells with text in Excel, and it is used when you have to count specific words in Excel. To count the cells with the specific value, you can just enter the text to count within quotations in the formula. Suppose you want to count the occurrences of a particular word in a range of cells. You can just enter the formula to count the occurrences of the particular word in the given range of cells. Knowing how to count cells with text in Excel is essential for using some functions in Excel. Hope you learned how to convert text to numbers in Excel. Thank you.
Hello everyone and welcome back to this course on Excel for Business Analysts. We've made it all the way down to section 4, and in this section we're going to be talking about how to make better decisions using logical functions. And more specifically in this first module we're going to concentrate on one of the most popular logical functions, and that is the IF function. Now if you're looking for the IF function on the ribbon, you'll find it under the Formulas tab in the Functions library underneath Logical. This is where you have a list of all of the functions that belong to that logical functions group. Now, if you're not entirely sure what a logical function is, don't worry too much. I'm going to explain it from the very beginning. So what I have on the screen here is a very basic spreadsheet. It is a list of tech sales for a technology company called Microworld. And you can see in column A, we have the product that they sell. We have the customer, we have the date, we have the item cost, the number of items, and the total cost. And what you'll see is that the total cost, if we look up in that formula bar, is basically D7, the item cost, multiplied by E7, the number of items. That is how we get to our total cost figure. And what we want to do here is we need to work out the shipping and the total. And in order to do that, we're going to use the IF function. Now, when it comes to working out the shipping, we have some useful information just above. So you can see here, it says that there is no shipping charge for orders over $1,500, but for everything else, there is a 2% of the total cost shipping charge. Now, if we just jump in here and type in if and open a bracket, you'll see the arguments that we have. The first thing that's highlighted is the logical test. And then essentially, depending on if that logical test is true, you get one value. If the result of the logical test is false, you get another one. So taking a look at our example here, what would be our logical test? Well, we know that there is no shipping charge for orders over $1,500, but there is for anything under $1,500. So our logical test is going to be if the total cost, F7, is greater than or equal to 1,500. And you'll find that with a lot of logical functions, you're going to use those operators, the greater than, less than, equal to, so on and so forth. So that is our test. Is the total cost greater than or equal to 1,500? Let's press comma and move on to our next argument. So now we want to say, what do we want Excel to do if that is true? So if the total cost is greater than or equal to 1,500, what do we want to do? Well, I can see here that there is no shipping charge for orders over 1,500. So I'm going to say I want Excel to do nothing. Comma. What do we do if that logical test is false? So if the total cost is less than 1,500, what do we need Excel to do? Well, if it is less than, I want Excel to work out what 2% of that total cost is and use that as the shipping charge. So we're going to say F7 multiplied by 2% and close our bracket. Let's hit enter and see what we get. So I've got the first number inputted there. It's showing me $29. And what I'm actually going to do is just apply some accounting format to this column. And I can double click the autofill handle to copy that formula down. And what we should see, and it's a very nice quick way to be able to do a visual check, is that anything that's equal to or greater than 1500 should have no shipping charge. So I can see here where we have a dash that one is over 1500. And I can see as I scroll down that appears to be true. Everything else that's under 1500, we've worked out what 2% of the total cost is, and we've got that as our shipping fee. So just to recap again, we have logical test, value if true, value if false. And our final calculation in the totals column is a very straightforward sum calculation. So we're simply going to add the total cost, F7, to the shipping cost, G7. Close the bracket and hit enter. Once again, I'm going to apply some accounting formatting to this column, and I'm going to double click to copy that down. And now we have all of our figures. So very quickly, we've been able to work out everything we need for this particular data set. Hopefully that explains how if works a little bit more. We're going to move on to some more examples of if, so please join me in the next module for that. Hello everyone and welcome back to this course on Excel for Business Analysts. We're down in section 4 where we're taking a look at logical functions, and in the previous module we took our first look at how to utilize that if function. In this module we're going to do another example of if on slightly different data. So in front of me here I have some employee data, so this might be for somebody who works in HR. And what we have in column A is a list of employee names. We have the building that they work in and their department. We have the hire date, the years that they've been employed, their salary, and then they've been given a job rating. So this job rating might be something that's been generated from a yearly appraisal, and each staff member has been ranked from 1 to 5. And depending on what they've been ranked determines if they get a bonus or not. And we're going to utilize the if function in a couple of different ways to work out who is going to receive a bonus. So what we're going to say here is that anybody who has achieved a job rating of 5 is going to get a bonus of $3,000. So I'm going to click in cell H2 and we're going to fire up our if function. And if you remember from previously, we need to first state our logical test. So in this case, our logical test is if the job rating, G2, is equal to 5, comma, what happens or what do we want Excel to do if that is in fact true? Well, if the employee has a job rating of 5, they're going to get a bonus of $3,000. If they have anything that isn't 5, they're going to get absolutely nothing, which is a little bit unfair, but there we go. Close off the bracket, hit enter, and now if I copy this down by double-clicking the autofill handle, we'll see that we have 3,000 listed wherever there is a job rating of 5. So it's very easy for us to then see which staff members have received that bonus. And once again, I'm going to highlight this column and I'm just going to apply some currency formatting. So now let's take this on a stage further. I'm going to double click to jump back into my if function. And what we're going to do here is instead of having just a 0 or a dash, we're going to replace that with some text. So I'm going to remove the 0, and what I'm going to say is that if the job rating is equal to 5, I just want it to say in the cell bonus. And when you're dealing with text within a formula, you must always put it in quote marks. Comma. What do we want it to say if the logical test is false? Well, I want it to say no bonus. And hit enter. And now if I double click to copy that down, you can see we get those results. So essentially what I could do if I wanted to quickly analyze this data and just get a list of everybody who's going to receive a bonus, I could do that very quickly by combining this with some filters. So I'm going to jump up to my data ribbon, make sure that I'm clicked somewhere in this heading row, and I'm going to click on the filter button. This applies these little filters to each of the heading rows, and what I can then do is filter just for bonus. Click on OK, and it's going to show me all of the people who are going to receive a bonus. Now, so far in the two examples that I've shown you, I've been hard coding values into this particular formula. So I hard coded in $3,000 into that if formula, which means if the bonus amount changes, I'm going to have to go into my formula and I'm going to have to change it. What I could do is, if I wanted to, have my bonus listed somewhere else. So maybe I could have bonus just here. And then underneath it can say 3,000. And I'm going to apply some formatting to that. And instead of actually hard coding 3,000 into the formula, I can then utilize cell references. So let's do our formula again. Equals if, open bracket, our logical test is if the job rating is equal to 5, comma, if that's true, then they're going to get a bonus of 3,000, but we're going to utilize the cell reference instead, J4. Now remember, because we're going to copy this formula down, we want to make sure that we fix this cell J4 so Excel doesn't try to move down one cell. So we're going to do that by pressing our F4 key to add dollar symbols in front of the row and the column. Comma. If they don't have a job rating of 5, then they're going to get 0. And then of course we can copy that down and we get our result of 3,000, but the difference being, if I want to very quickly update this bonus to 3,500, I just need to change it in one place and all of my figures are going to update. The final example I'm going to show you in this module is if we want to maybe set the bonus as a percentage of their salary. Again, if we jump into cell H2 and say equals if, open bracket, our logical test is exactly the same. If the job rating is equal to 5, comma, if that's true, then they're going to get a bonus of 15% of their salary. So I want to say salary, which is F2, multiplied by 15%. And as I was saying previously, I've hard-coded the 15% into the formula, but you could very simply have the 15% listed over at the side in a different cell and utilize the cell reference. Comma, if they don't have a job rating of 5, they are going to get nothing once more. And we can go in and copy this down, and there we can see our figures. So a few different ways there that you can utilize the if function in various different formats, utilize text, utilize cell references, etc. in order to extract the results that you need. In the next module, we're going to move on to something called nested if statements. So please join me for that. Hello everyone and welcome back to this course on Excel for business analysts. We're down in section 4 where we've been looking at logical functions and in particular the if function, one of the most popular functions in Excel and something that you really need to wrap your head around if you work in business analysis. Now in the previous couple of modules we've taken a look at some basic examples of if and how you can utilize it in different ways. In this module, I want to move on from that idea and just show you how you can construct what we call a nested if statement. Now, when we say a nested if statement, what we essentially mean is an if statement or multiple if statements within an if statement. Now that might sound a little bit confusing at this stage, but hopefully this very simple example using the data we used in the previous module will make it all a lot clearer. So once again, just a reminder of our data. We have employee names and we have the building department that they work in. We have their hire date. We have the years that they've been employed, their salary and their job rating. And in the previous example, we were giving out bonuses for all of the employees that had a job rating of 5. Now it seems a little bit stingy to only give employees that have a job rating of 5 an annual bonus. So what we're going to do is we're going to dish out some more money using nested ifs. So I'm going to jump into cell H2 and we're going to start off with our equals if function again. Now our logical test is going to be the same. So if the job rating is equal to 5, comma, and I'm going to start out by hard coding in what the bonus is going to be if that logical test is true. And just to keep things consistent, we're going to stick with 3,000, comma. Now this is where the nested part comes in, because what I want to do now is say if the job rating is 4, the employee is going to receive $1,500. So instead of providing a false argument at this stage, I'm going to add in another if and open the bracket. And I'm going to do exactly the same thing. If the job rating is equal to 4 this time, then that employee is going to get $1,500, comma. Let's add in another one. If, open bracket, the job rating is equal to 3, then the employee is going to get $900 bonus. And we can carry on going. So let's do one more, comma. If the job rating is equal to 2, then they're going to get $500 bonus, comma. And what I'm going to say is that if somebody's got a job rating of 1, then they're not going to get anything. So we're going to say comma, 0 on the end. Now with these longer nested if statements, what you need to remember is that for each bracket that you've opened, you need to close off as many at the end. So I can see that I have 1, 2, 3, 4 open brackets, so I need to close off 4. 1, 2, 3, 4, and hit enter. Now the first one is showing me nothing, and that is a job rating of 1, so that appears to be correct. I'm going to copy this formula down, and what I should see is that I have figures filled in for anyone with a job rating of 2, 3, 4, or 5, and whenever the job rating is 1, there is no bonus. So that appears to be working very nicely using those nested if statements. And as you can imagine, if you have a lot of data, these can get pretty long. And in the next module, I'm going to show you a way that you can kind of shorten this up a little bit. But it's really important that you understand this concept of nesting functions inside other functions. Now, of course, as we saw previously, we could also utilize cell references to construct our nested if statements. So what I've done here is I've just added a little table over at the side that shows me the ratings 1 to 5 and the bonus for each of those ratings. So instead of hard coding these numbers into the formula, which makes them a little bit more difficult to change, I can just reference the cell from this little table instead. So let's take a look at how that would look. We're just going to say equals if, open bracket, our logical test is the job rating. If that's equal to 5, then they're going to get a bonus of 3,000, which is cell K8. And remember, we need to lock that in place by pressing the F4 key to make it absolute, because we're going to copy this down. Comma, if, open bracket, the job rating is equal to 4, then they're going to get a bonus of 1,500 and lock that in place with the F4 key. And I could carry on going as I did before, but in this case, I'm just going to leave it there. I'm going to do my final argument. For anybody else who hasn't got a job rating of 4 or 5, they're going to get nothing in this case. and I need to close off 2 brackets because I've opened 2. Enter, and then double click to autofill that down. And of course, as we've seen before, if these numbers now change, everything is going to automatically update. So let's change the bonus for a job rating of 4 to 1700, hit enter, and all my numbers have updated very simply. Hopefully those examples have demystified nested if statements a little bit more for you. In the next module, I'm going to talk to you about the newer IFS function, which really makes nested if statements a lot more concise and a lot shorter. So please join me in the next module for that. Hello everyone and welcome back to this course on Excel for Business Analysts. We're down in section 4 where we've been taking a look at how to make better decisions using the if function. And in the previous modules we've seen a couple of basic examples of how to utilize if, and we've also looked at how to utilize nested ifs, that is, if statements within if statements. And if you remember, we had a very small example. But when working with nested ifs, the formula can become quite long and quite cumbersome. Imagine if you had a lot more data and a lot more if statements that you need to add in, that formula would become extremely long. So what we're going to do in this module is we're going to take a look at Excel's new alternative to working with nested ifs. And that is the IFS or the IFS function. I like to call it IFS to differentiate from regular ifs. Now, one thing to note here is that the new IFS function is not available in all versions of Excel. So if you have Excel 2016, 2019 for Office 365, then you should find that you have access to the IFS function. If you're not sure which version you're using, a very quick way of checking if you have access to the function is just to click in a cell, type it in, and if you can see it listed underneath, then you are good to go. If you don't have this function, then you will need to use nested ifs, as I demonstrated in the last module, until you upgrade and have access to this new function. So let's take a look at how the IFS function works. So I have an example on my screen here, and this is just some test results for an English exam. And I have these student names, I have their score, and what I want to determine here is whether they passed, failed, or if they need to retake. And just above, I have the threshold, the pass mark they need to achieve. So essentially, if they score above 75%, they have passed. If they score below 75%, they have failed. And what we're going to say is if they have achieved exactly 75%, they're going to need to retake the exam. So I'm going to use the IFS function in order to populate these empty cells in column C with the result. So let's jump into our first cell, C6, and I'm going to type in equals ifs and open my bracket. Now the difference with IFS as opposed to nested ifs, if you look at the arguments underneath, we're only required to provide a logical test and a value if true. We don't need to provide a value if false, and that essentially makes this formula a lot more concise to read and a lot more concise to construct. So let's type in our first logical test. We're going to say if the score, which is in cell B6, is greater than 75, and we're going to lock that cell because we're going to copy this down by pressing the F4 key, comma. If that is true, then the student is going to pass, comma. You'll see now it moves straight on to logical test 2. We haven't had to provide what we want Excel to do if it's false. So let's do the next logical test. If the score is less than 75, and we're going to lock that by pressing F4, comma, we're going to say fail. Now for the time being, I'm just going to do those two. I'm going to close off my bracket. I'm going to hit enter and I'm going to double click my autofill handle to copy that down. So we can see here we have anything under 75 is listed as a fail and anything over is listed as a pass. But take a look at this score here, which is dead on 75. Currently that's telling us NA, it's giving us an error. And that is because we haven't told Excel what we want it to do if the score is 75. All we've said is if it's above 75, it's a pass. If it's below, it's a fail. Now this is fairly easy to solve. What I could do is just jump back into my formula, click on the end, and provide another logical test. So I could say if the score is equal to 75 and lock that in place, then I want it to say retake and hit enter. And now if I send that down, I get exactly what I'm looking for. Now there is another way that we could deal with this. Now it's perfectly fine to do it that way. And because I have a fairly small data set, it's very easy just to add in that third logical test. However, there is a slightly different way that we could do this. I'm just going to remove that last logical test that we added in. And instead of actually providing that logical test, I'm just going to type the word true, comma, and I'm going to say retake. Hit enter, and if I copy that down, I should find that my results don't change. So why is this working? What is this true argument and what exactly is it doing? Well, the way that this formula works is that Excel is looking for the first true condition in order to produce a result. So if we take this first score, for example, 67, essentially Excel starts to run through this formula looking for the first true result, and then it returns whatever text that corresponds to that. So if I just highlight this first logical test, and what we can do here is just calculate this formula so we can see the results. You can either press the F9 key, or on the formulas ribbon, you can choose the calculate now option. You can see that this first logical test calculates to false for this first score. So what Excel does, it says, okay, that's a false. It moves on to the next calculation. So if we highlight the next logical test and do F9 or calculate now, it finds true and so returns the result of fail. And it basically goes through all of these and does exactly the same process. It's looking for the first true. When it finds it, it will produce the result that relates to it. Now with this one here, where it's dead on 75, let's double click. Let's highlight and do F9 or calculate now. We have a false. It moves across to the next one. We still have a false, and so because we've hard-coded true as our third logical test, it's going to produce true. So this is a nice kind of catch-all option to add into your formula. Now just to finish off this module on IFS, one little thing you might want to do to make these stand out a little bit more is combine this with conditional formatting in order to maybe highlight the results which are showing as fail, or maybe highlight the results that are showing as pass. So let me very quickly show you how you can do that. I'm going to start out by highlighting all of my results. I'm going to go up to the home ribbon and across to conditional formatting, and I'm going to create a new rule. I'm going to select a rule type. I'm going to say format only cells that contain, and then because my cells contain text, I'm going to make sure I say specific text containing, and let's say the word pass. I want all of those results formatted in a green color. Click on OK, click on OK again, and now I can very easily see all of the people that have passed this test. You could, of course, go through and create another rule to highlight the results that are fail, or maybe the ones that are retake as well, but that's just a nice way of combining conditional formatting with IFS in order to analyze your data a little bit more effectively. I just want to finish off this section on logical functions and if statements by talking a little bit about how you can use ifs to handle errors in your spreadsheets. Now, if we take a look at this example just here, we're fairly familiar with this data. This is that bonus spreadsheet we were looking at previously. Now, in this bonus column, if we take a look at the first formula, I've basically set up a formula to work out the bonus only for people who have a job rating of 5 or 4. And so you can see that reflected in this column. So where they have a job rating of 4 or 5, we have the bonus amount. Anything under 4, so 1, 2 or 3, we have an NA error in the cell. And that's because I haven't accounted for job ratings 1, 2 and 3 in this particular formula. Now, it might be that you are happy to leave your spreadsheet looking like this, but what I will say is that if you do have a spreadsheet that has lots of errors contained within cells, even if those errors are correctly there, which they are in this case, it makes your spreadsheet not only look a little bit messy. If you were to send this to somebody else who's maybe not familiar with the data, they might think that these are actual errors that need to be fixed. What would be much better here would be to add some meaning to these NA errors. So maybe instead of NA, I want it to say no bonus, which makes it a lot clearer. Now we can do this by using error handling formulas. And if we jump up to the Formulas tab in this logical group, you're going to find the two that we're going to use in this lesson in here. We're going to take a look at IFERROR and IFNA. Now let's start out with IFNA. Now what IFNA will do is it will help you deal with any NA errors that you have in your spreadsheet. Now NA isn't the only type of error that you might see in cells. You might see a div error or a value error or a name error. And all of these different errors mean different things. But if you specifically have an NA error in a cell, you can use the IFNA function to assign meaning to that. Now, as we do have an NA error, we're going to use that function. Now, what I want to do here is let's select the first cell that contains a formula. Let's jump up and edit this in the formula bar. Now, what we're going to do is we're going to type in IFNA. That's the formula we're going to use. Now notice underneath this particular function has two arguments, value and value if NA. So in other words, value if we find an NA in the cell. Now the first argument, the value, well the value in this cell is generated by that IFS formula. So effectively the IFS formula is our first argument, it is our value. So we can click on the end, press comma, and now all we need to do is simply specify what we want to say in the cell if it comes across an NA error. Well, I want it to say no bonus. We need to add this in quote marks and close the bracket. So we've wrapped an IFNA formula around our IFS formula. Hit enter and take a look at that. Now, if I copy this down, I've replaced all of those NA errors with something that is a lot more meaningful, a text string that says no bonus. Now, the IFNA formula can only be used when you have NA errors in your spreadsheet. And as I said, there are lots of different types of errors that you can get in a cell. And for any other error, you can't use IFNA to assign any meaning. That is where we would use the second error handling formula, IFERROR. IFERROR works in a very similar way to IFNA, but it will handle all types of errors, not just NA errors. So let's take a look at this in action as well. Now, if we jump across to the IFERROR spreadsheet, if you recall, we put together a little formula here, and again it's an IFS formula, which gave us the day of the week when we enter in a day number. And what I said was that if somebody enters a day that isn't 1 to 7, so for example 8, it's going to produce an error because the formula doesn't account for that. Now in this case I am getting an NA error again, so I could effectively use the IFNA error handling. But we're going to do this in a different way, and we're going to use IFERROR instead. So IFERROR we can use for any type of error, and we edit the formula in exactly the same way. So we're going to type in IFERROR at the beginning. We have the same two arguments, value and value if error. The value, again, is going to be generated by our IFS formula, so we can go right to the end, press comma, and then we can enter in what we want it to say. Now, in this case, I wanted to say please enter a number between 1 and 7. So what I'm doing here is basically giving the user a little bit of guidance if they enter an incorrect value. So let's hit enter, and there we have that piece of text. And if I choose a different day, it doesn't come up. But if I put in day number 10, I'm going to get that piece of text. So using error handling in this way can really help you keep your spreadsheets consistent, meaningful, and easy to understand for anybody who might be using them. The only takeaways here are if you have NA errors in the cell, you can use IFNA or IFERROR. If you have any other type of error, you can only use IFERROR. The new let function is part of the logical group of functions in Excel. And what let basically allows you to do is assign names to calculation results inside a formula. So if you find yourself writing the same expression multiple times in a formula, let basically allows you to name the expression, and then Excel will calculate the result using the name. So not only is this a great time-saving function, but it also makes your formulas easier to read and understand, as you don't have to remember what a specific cell reference or range refers to, because it's right there in the formula. So let's start out taking a look at the let syntax, and also let's run through a couple of basic examples. So in cell A4, I'm just going to type in equals let. And you can see here the different arguments that we have for the let function. We have name1, name value1, calculation, or name2. So name1 and name1 value are where we define the name and the value. And then the last thing we do is the calculation. And we could have numerous pairs of names and values in our formula. In fact, the let function supports up to 126 pairs. Now, you might be listening to this thinking, okay, I kind of understand what you're saying there, but it doesn't really make sense. And that is completely understandable, because this is one of those formulas that only makes sense when you see it in action. So let's take a look at a very basic example. So the first thing I'm going to do here is I'm going to assign a name to a variable. And for argument's sake, and because I'm not very good at thinking up variable names, I'm simply going to call this first one var, comma. Now I can assign a value to the word var. So if I assign the value 20 to this word, effectively the word var now represents 20. Now I could carry on going, adding other names and values, or I could perform a calculation using the variable that I've just set up. So if I now do a calculation, it might look something like this. I could say var plus 5. Now what do you think the result of that calculation is going to be? We've stated that var equals 20. That is our variable. Those are our parameters. And now my calculation is var plus 5. So as we would expect, the result is 25 because we're just adding 20 to 5. So that's an example of a simple let just using one variable. Let's add another variable. So if var is equal to 20, let's add another variable. I'm going to say comma, and remember, our next argument is calculation or name2. So this time we're going to add another name and another name value. So let's say that x is attributed to the value 10. So now what I could do is I could modify my calculation at the end here, and I could do var divided by x. What result do you think I'm going to get? Well, I'm going to get a result of 2. Because we're effectively doing 20 divided by 10. So hopefully you're getting the idea here. We set up a name, we attribute a number to that name, and we can set up 126 different pairs of names and variables in here if we want to. The last thing we do is we perform calculations using the variables that we've created. So everything is defined within one formula. Let's define a third variable. So let's double click to edit the formula. We're going to click after the second variable, and this variable we're going to name y, and this is going to be 5. I'm now going to change my calculation to do var divided by x, and I want it to do this part of the formula first. So we're going to put it in brackets, and then I want it to plus y. Let's hit enter. We get a result of 7. So we're doing 20 divided by 10, which gives us 2, and then we're adding 5. Let's take a look at another example of using the let formula. So if we scroll down, again, we just have a basic table that shows some employee names, and we have their salary. And each of these employees is going to get a bonus of 20%. So this is a fairly simple calculation. We can just simply do a sum, and we multiply the salary by the bonus, and we need to make that absolute, and then we add the salary onto the bonus. Let's close the bracket and hit enter, and we get our result of 54,000. So how could we use let to perform this calculation? Well, let's click in the cell underneath, and I'm going to do this up in the formula bar and just show you a slightly different way to put together your calculations. Now, this formula bar isn't a set size. If you notice, if I hover my mouse over the bottom part of the formula bar, we get a double-headed arrow. So if I click and drag this down, I get a much larger formula bar. And sometimes when you're putting together more complex formulas, it's really helpful to be able to lay them out in the formula bar and have different parts of the calculation on different lines. It just adds to the readability of your formulas. So let's go into let. Open the bracket. Now I'm going to declare my variables on the next line. So we need to press Alt-Enter to move our cursor down. So let's declare our first variable. Well, what do I select first when I'm doing the sum calculation? I select the salary cell. So I'm just going to call this first variable salary, and salary is going to reference cell B17. What's the next part of my sum calculation? Well, we multiply the salary by the bonus. So the next variable that I'm going to declare, and let's put it on a new line, Alt-Enter, is going to be the bonus. And the bonus is cell F15, and we need to press F4 to lock that. So now we've declared our two variables, we can perform our calculation. So Alt-Enter to move on to the next line. Our calculation is going to be sum, open bracket. We're doing the salary, and notice as I start to type it in, it comes up in Excel's IntelliSense, so I can simply press the Tab key to select it. We want to multiply by the bonus. Again, it's come up, so Tab key to select. And then we want to plus the salary again. Close the bracket and close off our let. So that is our calculation on the last line. Now take a look at the way that we've structured that. It makes it a lot easier to read. We have our function name on the first line. We then have our variables declared on lines 2 and 3. And then at the bottom, we have our calculation. Let's hit enter and see if this works. And in fact, yes, it does. So now all I need to do is double click and I can copy that formula down. So hopefully now you're getting the idea as to how this let function works. Let's take a look at one last more complex formula. So let's move to our final worksheet. Now this data may look familiar to you. We did use this when we were looking at the filter function. I have some block names, we have the subject, and we have the pass mark. So this might be information for students who took a test. And basically what I want to do is use the filter function to return the block, the subject, and the pass mark based on the criteria that we have in the middle here. So currently, if I was using filter, I'd only want to see results where the block equals West and the subject equals English. So let's first just do this using the filter function, and then we can see how we can convert that into a let. So let's type in equals filter. Our array, well, our array are the results that we want returned, which is pretty much everything in this table, comma. Now we need to specify what we want to include. So let's open a bracket. I want to include all results where the block equals west. So we need to select the block range, and that needs to equal what we have in cell E3, F4 to lock. Let's close the bracket. We also want to return results where the subject is English. And because this is an AND calculation, we want to return both results. We're going to separate with an asterisk. Open the second bracket. Select the subject range, and that needs to equal what we have in cell E7, F4 to lock. Let's close off our bracket, close off our filter, hit enter, and would you take a look at that? There are our results. So we're going to do pretty much the same thing, but we're going to set this up as a let instead. And this is where lets can be particularly useful, because if you take a look at this filter formula, notice lots of cell references in here. So we can effectively replace these cell references with more meaningful names using let. And this is particularly useful if you have repeating cell references in your formula, because it means that you can declare the name for a particular cell reference and then just replace every time that cell reference occurs with the name. And not only does it make the formula a lot easier to read, it's a lot more efficient for Excel to calculate. So let's jump down to cell G9, and we're going to construct this as a let. Now I might need a bit more room here, so let's drag our formula bar down. So we're going to do this in the same format. We're going to start with our equals let. We're going to open a bracket and Alt Enter to move on to the first line. So now we want to declare our variables. Now the first thing we selected was our array, which is basically everything that we have in this table. So I'm going to call this array, let's just call it data. And then we can select the cell references, comma, Alt Enter to move to the next line. What do we then need to do? Well, we need to specify what we want to include in our filter. And the first thing is we want to include the block. So we're going to name the block range. So let's give it a name. We'll call it block, comma, and that means we're referring to this range just here, comma, Alt Enter. Now you don't necessarily have to name absolutely everything that you select in your calculations as a variable. For example, I might not want to name this cell just here where we have West. Now I am going to do this just so you can really see what this formula looks like when we name everything. And I think what I'm going to do is I'm actually going to rename the block range. I'm going to call this block RNG just to make that very specific. And then the next variable we're going to call block, and that's going to refer to this cell just here. And we're going to press F4 to lock that. Comma, let's move on to the next line, Alt Enter. The next thing we need to declare is the subject just here. So let's say subject RNG is this range just here, comma, Alt Enter. And again, if you need to, you can just drag this down to give yourself a little bit more room. And then our final variable to declare is just going to be the subject. And that is going to be this cell just here. And I'm going to press F4 to lock that. So those are all of our declared variables. We can now perform the calculation on the last line. So comma, Alt, Enter. So now it's time to put together our calculation. So we want to do our filter. Our array, well, we've declared that as the data range, comma. What do we now want to include? Well, the first thing to include, we want to select the block range, and that needs to equal whatever we have in the cell that we've called block. Asterisk, our second piece of criteria, is the subject range, and that needs to equal the subject. close our bracket, close off our filter. So let's just take a moment to review what we have in this calculation. We have the let function name on the first line. We then declare all of our variables and what they refer to, and then we do our calculation on the last line. So let's hit enter and see what we get. Now it's telling me it's found a typo in my formula, and I think I've missed off a trailing bracket on the end here. So I'll say yes to accept the correction and take a look at that. We're getting exactly the same results. So our let is working really well. Now let's just check if we change this to east. Let's see what happens. It still works. So hopefully that gives you an idea as to how you can use let and where it might be useful. I will say let is particularly useful if you have a large data set, if you have a complicated calculation, and particularly if you're recalling the same information over and over again in a formula. It makes it a lot more efficient for Excel to calculate, and it makes the formulas a lot easier to read and understand. In this lesson, we're going to blast through some of the most useful date and time functions in Excel. And we're pretty much going to cover most of the date and time functions that you're going to come across. So on this worksheet, we have a column A, that contains a date. And this date is currently in short date format. And we then have an invoice total. And what I want to do is I want to extract certain parts of this date into separate columns. And we're going to do this using date functions. Now, the majority of these that I'm going to show you rely on the fact that we have the full date in column A, because we're going to use this column as our reference point to extract the various different parts of this date. So effectively, we're breaking up this date into its different parts. And I'm going to show you a function in a moment that kind of does the opposite. So if you have things like the day number, the month number, and the year, how you can combine them all together into a short date format. But let's not get too far ahead of ourselves. Let's run through all of these different functions. So in column C, we want to extract the day number from the date in column A. So we have a function called day. Now notice there is only one argument for this, and that is serial number. And this is slightly misleading because what Excel means by a serial number is just the cell that contains the date. So in this case, A4. Close the bracket, hit enter. It's extracting the day part of this date. So in this case, 10. I can then double click, which is going to copy that formula down and extract the days for the rest of the date. Super easy. Now, what if I want to extract the day name from this date? And what I mean by the day name is Monday, Tuesday, Wednesday, Thursday, so on and so forth. Now, this works in a slightly different way, because if the answer that you want to extract from a date is a text-based answer, such as the day name or maybe the month name, you need to use the text formula. This function has two arguments, value and then format text. Now, the value, again, is just the cell that we want to extract from. And then we need to provide the format for this day. So this is where those MMMs and DDDs come in again. So if we're extracting the day, we want to use the D, but how many Ds we use will determine if I get MON, M-O-N, or Monday. And this needs to go in quote marks because it is essentially text. Now, if I type in 3 Ds, first of all, and close my quotes and hit enter, I'm going to get the short version of the day name. Let's double click to edit. If I was to add another D in here and hit enter, I get the long day name. And then I can double click to copy that down. So just remember that when you're trying to extract things from dates, if it's text, you need to use the text function. Let's move across to the next column because this time we want to extract the month number. And for this, we use the month function. Again, one argument, which is the serial number, A4, close the bracket, hit enter, and we get the month number part of this date. Now, once again, the next thing that we're extracting is the month name. So this is going to be January, February, March, and this is text. So we need to use the text function again. Let's select our value, which is A4, and then we can choose our format, which needs to go in quote marks. So this time we're dealing with the month, so we want M's in here. If I do 3 M's, I'm going to get the short version of the month, so Jan, Feb, Mar. If I put 4 M's, I'm going to get the long version of the month. Let's hit enter, and then of course I can double click to copy that down. Really straightforward. The next one is super easy. We're extracting the year, and we have a year function. You guessed it, serial number, close the bracket, hit enter, and it's going to extract the year part of that date. And then finally, I can extract the weekday number. And we can do that using the weekday function. Now, the first argument here is the serial number, so we need the date again. And now we can specify how we number our weekdays. Now, I tend to number mine as in Monday is 1 all the way through to Sunday being 7. But some people in different parts of the world number their weekdays differently. Some people might start their week on a Sunday, and so that is number 1 to them. Some people might start on a Thursday, so on and so forth. And this is the argument where you can specify exactly that. So if I choose to put a 2 in here as this argument, it's going to number Monday as 1 through to Sunday 7. And that is exactly what I want. Close the bracket, hit enter, and now I get the weekday number. Double click. So if I just take a quick look at this, this first one is 4, and yes, Thursday, according to me, is day number 4. And if I wanted to get super fancy, and this will even give us a chance to practice a quick if statement, I could type in an if statement here which tells me if this date effectively in column A is a weekend or a weekday. So what I could say here is equals if my logical test. Well, what I can say is if the weekday is greater than 5, if that is true, then yes, it's the weekend. If it's not, then no, it isn't. Because Saturday and Sunday are effectively numbered 6 and 7. So if I hit enter and then copy this down, I should find that most of these are no, except when we get to anything that is a 6 or a 7, which will be yes, because these represent Saturday and Sunday. So some really useful functions in there. Now, I mentioned earlier that we can in fact do the reverse of that and combine values together to create a date. So if we take a look at this table at the top here, you can see I have the year in one column, the month in another column, and the day in another column. So what I can do here is use the date function. And all I need to do is specify the cell. So the year is cell K4, the month is L4, and the day is M4. Close the bracket, hit enter, and I get that date, which I can double click and copy down. I could do exactly the same for time. So equals time. We need to specify the hour, the minute, and the seconds. Close bracket, hit enter, and there I get my times. Super useful functions. Now let's jump across to the time functions worksheet, because I just want to finish off by showing you how we can do pretty much exactly the same, but this time using time as our serial number. So I have some times in this first column, and we can break those down using more functions in Excel. So the first one is the hour function. Again, it just requires a serial number, and it's going to pull out of that the hour. Double click to copy down. We have a minute function. Again, serial number is required, and we can double click to copy that down. And then finally, we can add the seconds by using the second function. Serial number, close the bracket, hit enter, and then we can double click to copy that down. Now, because of the way that I have these times, these last two are just showing zeros, and that is actually correct. It's really only this first column that has different values in it.
Hello everyone, welcome to a new tutorial from Simon Says It. In this video, let us see how to randomize a list in Excel. In some lists or tables, there might be the need to shuffle the entries randomly. We randomize the entries of a list or table while picking any random criteria in an unbiased way. Now let us see two ways to randomize a list in Excel with an example. One way to randomize a list is to use a combination of formulas in Excel. You can use the sort by formula with a combination of rand array and COUNTA functions with a few criteria to randomize the list. First, select any destination cell to create the random list. Enter the formula in the destination cell and press Enter. This creates a random list of entries from the selected range of cells onto the destination cell. The second method just employs the rand function to create random values and randomly sort the data. However, it employs a couple of steps to arrive at the randomly sorted data. First, select a destination cell. Enter the formula and press Enter. When you press Enter, a random value populates in the cell. Use the drag handle to apply the formula to the remaining cells. As of now, it makes no sense, and the values are not random yet. Now, with the selected cells, navigate to Data. Under the Sort and Filter section, click on Sort. You can sort the random values, either ascending or descending. Excel throws a warning suggesting you select the data adjacent to the random values. Select the Expand the selection and click Sort. Once you click on Sort, the random values will be sorted out along with the values. You can delete the random values and just keep the list that has been randomized. That is all, everyone. In this video, we saw how to randomize a list in Excel in two easy ways. Thank you.
If you're not a subscriber, click down below to subscribe so you get notified about similar videos we upload. To see the full course that this video came from, click over there. And click over there to see more videos from Simon Says It.